Hi guys, I'm Darren and welcome to the video. Today we're going to be taking a look at a new flight controller, but not from the usual suspects. So how does this compare? Let's take a look. The first thing that you might say is, hang on, didn't he say this was a flight controller? Oh, what's this? This looks like an antenna to me. And yes, so this is something slightly different from FrSky. This is actually the R9 Pilot flight controller. So let's get it out of the bag. So this is how it all will come, and this is what we get in the package. So we get a couple of manuals. There we go. So we got some jumpers. We have a bag of bits, so we have some DuPont connectors in white, red and black. We have an XT60 and we have this cable here, which I'll go into later, and some actually metal bolts rather than sort of the nylon standoffs we usually get. Okay, we've got two manuals. One is for the flight controller, the other is for the receiver. And then we have these two bags right here, which is where the more interesting part sort of starts. So I'd like to thank FrSky for sending me this for review. This is hopefully quite a nice alternative. So I'm going to be completely honest, like I am with all my reviews. So we'll go over this. We'll look at what is here, what's missing. And I've also added a page on my website, which I'm going to link to in the description, where you can select different flight controllers and then see the specifications of them next to each other. So that might be a handy comparison tool too. So what is this? You can see that it's not just a flight controller, it has got a receiver. There are actually three versions of this. This one is the R9, so it has an R9 over-the-air receiver. There's also an RXSR version, and there is a version that doesn't have a receiver at all. And obviously the prices reflect that. So at this time when I last checked, the version without a receiver is about $45, and the version with the receivers are about $10 more, so about $55, $56. So we're looking at similar money to other wing-based flight controllers. I should say this is an F765 processor, so we're already at, you're looking at sort of mid $50 for most of these wing flight controllers anyway. So without the receiver, it is actually slightly cheaper. Okay, so first up, let's look at the PDB side. So a few basic things to point out. They both have an arrow, so wiring up it's easy to get everything done. It's because they have this locating socket on here, so obviously they both need to be pointing in the right direction. So this arrow is useful for when you're wiring up, you know which way the flight controller and the PDB need to be facing. So it's just a nice little handy tip. Let's start at the beginning. So we have our power coming in. So these are on these two pads right here, and they're nice large size pads. I'd guess they're about 8mm, probably closer to 7mm square pads here for the main power input. Now this can take a whopping 3 to 12S, so that's 11.3 volts to, I think it was 51 volts. So a really big input voltage range on this. And one of the reasons for that is there's something missing that you may notice on other flight controllers, and that is a shunt resistor. Now that's usually used for for getting your current reading, but on this there is, I believe it's this chip right here, which is actually a Hall effect current sensor. So they're better because they decouple the main power side to the sensing side. There's not actually a physical connection between them. So it means that if you have any spikes or anything, it shouldn't actually do any damage on the main PDB side. as far as the current sensing part goes. Obviously it could go through other components, but it also means that you can potentially have larger current readings. So this one is rated for 150 amps maximum. I don't know what the continuous is, but even if it was half that, you're looking at 75 amps, which is still a fair current. But what I will do is will ask the question, and I will leave a little note down there just to say what the continuous current is, if I can find it out. So at the other side of that, we have two sets of ESC pads. Again, these are quite nice large pads. They are probably closer to 5mm square, and you can see the actual traces are pretty big as well. So there's quite a lot of area. You can see it actually continues underneath the exposed pad into this side of the Hall effect sensor, and then out to this side for the positive. So let's continue with this section here. So we have our first UART, we have our TX and RX for UART1, we have our two signal outs for the ESC, so signal 1, signal 2, we have two grounds, we have RX8 here, so we can use that for ESC telemetry, and we have 5V out. So if you're using this UART and you need power, you'd probably have to go for the 5V here, and then probably piggyback off of that ground and just run your both. If you're running two ESCs, just run both grounds to the other pad. So that's this section. So we mentioned the PWM out for your motors. These will obviously, of course, support other protocols like D-Shot, and that sort of leads us on to this section up here. So you can see the white divider line. Everything on this side, well, most of it on this side is actually your PWM outputs. So the top row is grounds. The second row they've called VS, which is the voltage for servos. And then the final row is the signals. So it starts at S3 and goes to S12. Now the last two is actually UART3 as well. So if you're using 12 servos, you wouldn't be able to use UART3. Likewise, if you want to use UART3, you wouldn't be able to use the 12 servos. So next we'll move along to this section right here. And what we have in the first is actually the TX for UART8. So you do have the full UART. You just have the RX down here, the TX up here, and again, ground and 5V. Right, so next we have, along the top, we have TX and RX for UART7, 5V and ground. The next row down, we have TX and RX for UART5 with a 3.3V and ground. So that would be a good place to put your GPS. Next we have VI, VO and VV and ground. So VI is video in, VO is video out, VV is video voltage, because again you can select what voltage you want, and G is ground. So next pins along, it's the last two here. We have TX and RX2. We have A in 1 and A in 2 for two analog to digital sensors, and the bottom two is DA3 and CL3, which is the data and clock for the I2C bus. The last little panel at the end is where you choose what voltages you want for the servo rail and for the video rail. The top one is video voltage set to 9V, which is selectable between, if you leave these open, it's 5V. If you put a solder blob between them to bridge them, or actually, that's probably what the jumpers are for. So you can put pins in and use jumpers. So then you can change your voltages on the fly. So yeah, if you jump these two, it'll go to 9V. If you leave them open, it will be 5V. And that the video side has 2 amps continuous or 2.2 amps burst. The VS side, we actually have two sets. So if they're all open, it'll be 5V. If you jump the bottom two, it'll be 6V. If you jump the middle set, I guess you'd call it, it'll be 7.2V. And if you jump both the bottom and the middle, it will be 8.16 volts going to your servos. So this will run really high power servos. The servo BEC has a continuous current of 5 amps and a maximum current of 6 amps. So overall, not too bad. Obviously, the current side is not as high as we've seen on some other wing flight controllers, but still it's probably fine for most situations. It's only going to be if you have a really large aircraft with bigger servos in that are going to be pulling, but for standard sort of 9 to 12 grams, be no problem at all. So that pretty much wraps up the PDB side, other than of course mentioning the socket. So this will actually transfer everything over that you need onto the actual flight controller board, which we'll look at next. So the flight controller part itself is actually very simple. There's not a lot of connections on here. Most of them are on the PDB, which means if you have an issue with the flight controller and need to replace that board, it's going to be a lot simpler job, and it'll be easier to work on things as well. So what we have on the bottom, we just have that header connector. We have a SD card holder, and this is actually a buzzer. FrSky just labeled this as a piezo audio transducer, which is basically a buzzer. So it's already on the board. You don't need an output for it. It's already there. And you'll notice these screw holes, they are for obviously connecting the accessories that can go on the top. So if we switch this over, we can see what they are. You'll notice this side, there's one already connected. You can see it's just a ribbon cable. And then under this cover here is the R9. Again, this could be the RXSR if you choose that receiver module. The space on this side is actually for a second external gyro. So if you wanted to use a different gyro, you could plug it in. It will all be sort of soft mounted, and you just screw it on with those screws. So there's the options there for that. We have a couple of buttons. So we have a boot button, and this button actually doesn't do anything at the moment. It probably could with firmware update, but at the moment it doesn't do anything. What we have here is a connector, and this is actually for your video. So we do have some video cables on the PDB, the VI, VO, VV and ground, but you could actually wire it through this connector to make things easier to take off. So this connector has pretty much everything. You can see the labels along the top, but basically we have ground, we have video out, we have video voltage, and we have TX1 for smart audio. Then we have the camera side, which has 5-volt out, ground and video in. So you can put all your video on this one connector, plug it and unplug it, and it is actually one of these latching connectors as well, so it's not going to just fall out unless you push the button down. What we have right next to it is the FrSky OSD. So this is the Pixel OSD, not a standard character based. So that is the general overview of this flight controller. Okay, let's plug it in. Let's see what version it's running. So you can see you can hear the buzzer, that's working through USB. The receiver is already working as well. And we're connected on COM9. So it's running a firmware version of iNav 2.6.0. Let's have a quick look on the ports. So UART8 by default is the serial RX, which seems a bit strange if that's what is next to the ESC section for ESC telemetry. That's a bit strange, but then I suppose we've got UART1 here as well, so we could use UART1. But of course, if you're not using that receiver, you could put it on any of these. It's a 765, so you don't have to worry about inversion. We have a SmartPort master peripheral, which is interesting. I don't know what that's doing. And we have, of course, the FrSky OSD, so that is on UART5. So that's still giving you 4 UARTs with nothing on whatsoever that you can use for whatever you like. So let's have a look in the receiver page. So it's actually using F port. That's interesting. And it's got the signal inverted automatically. So it's all set up, ready to go. So I guess what we could do is try and bind. Right, so I believe this is shipping with access on there. So what we should be able to do is just register and bind. So what I'm going to do is turn on the external R9MM or R9M module. I'm just going to set a random ID. 26 should be free. Fail save, hold. Right, so now what we should be able to do is switch this on and press the register button. I need something smaller. So what we have in the top of this plastic case is a little hole, and in there is the bind button. So we just want to press register, hold that button down. There we go. It seems to be at a slight angle, but you can hear it click. So anyway, that's got our name. So I'm going to rename this to R9 Pilot. So that's registered. And then of course we need to bind it. So disconnect the power. Go down to bind, click bind, power on, select R9 Pilot 1, 16 channel with telemetry. There we go, bind successful. So we'll connect back into iNav, go to our receiver page, and everything is working nicely. So yeah, that's quite a nice simple process. And of course the updates are the same, it's all over the air, so nice and easy. Just go to the update, plug in the receiver, it will pop up, and then choose enter. So right, let's see what options we get. So we can change the channel outputs for our 4 pins. We don't, I believe, do we have those? No, we don't have them because it's the flight controller version. F port is obviously switched on because that's what it's using to communicate with the board. We can disable telemetry, or we can have faster PWM. Again, we're not really using PWM, so it doesn't matter. So yeah, the receiver, nice and simple, straightforward, all set up. So it literally just needs wiring up to a plane and throwing, and it's all ready to go. Okay, so what is my final thoughts with this flight controller? We all know no product is perfect, nothing does everything, but obviously things have their advantages and disadvantages. So the first thing I want to mention that I didn't check in the actual video earlier is this is already fully integrated into iNav configurator. So you just go through, select the target, which is FrSky Pilot is the target, and that will flash to the board. That's already in 2.6, so it's not like you have to download a firmware from another site and upload it. It's already integrated. So let's go over the advantages and disadvantages. First, there is a cost advantage. It is about $10 or £10 cheaper than an equivalent F765 wing board. So there is an advantage there. The receiver on board, if you get the version with a receiver, that puts it at the same cost as the other wing flight controller, but you're still saving money overall. But there is advantages and disadvantages to that. You saw the advantage. It's already connected. You don't have to worry about anything. You just register it, bind it, and the job's done. So for new people, it's really simple. The hardest part was finding the bind button. So from that point of view, having it all integrated is, it's an advantage for particularly new people. Where that could be a disadvantage is separation potentially on the model. My current thoughts is I'm going to use this in the Dragon 2, and I'm going to put the flight controller as far back in the fuselage as I can. I'm not going to use the 2 little holes specifically designed for the antenna. I'm just going to put my own hole in the side and have it vertically mounted there. It will be fine, and then I can put the VTX and GPS in the wing. So it's all doable. It's just thinking outside the box slightly. It potentially could put it closer to the ESC, but I could actually, no, it doesn't on that plane. They're in the wings, so that's rubbish. So yeah, there'll be nice separation anyway. There are different ways of looking at it. If you did want to say you wanted to run your receiver in a wing, then it wouldn't make sense to buy the version with a receiver. If you've got a large model with bigger standard size servos, then this may not be the best idea, because the BEC only goes up to 5-6 amps maximum. You'd probably be better off with a higher current servo BEC. But if you're using 9 to 13 gram servos, which most of us are in our models, then this will be absolutely fine. You could probably go full house with this, so 4 servos in the wing, 2 in the tail, plus pan and tilt. You'd probably have no problem at all on that sort of setup with this 5 amp BEC. The video BEC, 5 volts to 9 volts for most cases will be fine. Now, there are some video receivers that like 12 volts, but yeah, I can understand why FrSky have gone this route. The minimum input voltage on this is FreeS, which goes down to 11.1 volts. So they'd need a boost on there if they wanted to have 12 volts supported all the time. Going to 9 volts, they can guarantee they're always going to get a 9 volt supply. The buzzer is quite nice. It's not so in your face as standard buzzers, which I know you can use them for model recovery. If it goes down in the field, you can have it so that the beeper turns on. But to be honest, I think probably the actual standalone recovery buzzer things are better for this. They're louder for a start. So for having just a beeper to give you feedback, I'd prefer the volume toned down a bit. So that's quite nice. It's not such an in-your-face loud buzzer. But yeah, other than that, it seems very well built. When you put it together, the actual connector that you sandwich between the flight controller and the PDB has a very positive click to it. So it seems very well built. All we can really do from this stage is test it in the air and see how it performs. There actually is one thing I forgot in the wrap up, and that is LED support. As it stands at the moment, there is no LED pad on here. However, I believe that it potentially could be possible to add LED support using one of the signal outputs. It could possibly just be something as simple as a different target in iNav, but that's the one thing. There is no dedicated pad for LED support. So that's one thing that's potentially missing that could cause you issues. I just wanted to raise that. Yeah, as I said, I'm not really I'm still very much learning when it comes to the development side of iNav. I'm just doing basic stuff, but if there is a way to change a target, just so maybe servo 10 is no longer a servo, it's LED support, that possibly could fix this issue. So yeah, if you absolutely must have LEDs, that is a bit of a game changer. So I just wanted to mention that. But anyway, back to the rest of the video. There'll be an updated target, hopefully in 2.7. So LED support within iNav. This all works in the configurator like anything else. The only caveat is you lose the last 3 PWM channels. As far as I know, the UART should still work on the last one, but I've not tested that yet. But yeah, so you end up with channels 1, 2, 3, 4, 5, 6, 7, 8, and 9. So you have 9 PWM channels, but you can have LEDs as well. So one less thing to worry about. See it. But yeah, looking at it physically and on the bench, it seems like a really good flight controller. So the only real question is, does it fit your needs? And of course, the only people who can answer that are yourselves. All I can do is give you the information. It seems decent. It seems well made. Other than that, the specs, it's all up to you. But I hope you guys found this video useful. If you did, please don't forget to give it a thumbs up. And if you haven't already, please consider subscribing. It will help get the information for this flight controller out to more people. And then they can decide, is it something that suits them or not? Just trying to think of any questions that people might ask in the comments. Would it support Crossfire? Of course. you just hook it up to a spare UART. GPS, compass will all be supported as well. It's got the I2C. You could have an external current sensor. It's got two ADC inputs, so you could have a current sensor, airspeed sensor. So yeah, it's a well thought out flight controller. But if you do have any questions, leave them in the comments, and I'll see if I can get them answered for you. So yep, thank you guys for watching. Again, like, subscribe, bell icon, get out, flying models like you style them. Have a great time. I'll see you.